Recording has started. Hey everyone, welcome to another episode of Open Cluster Management Community Meetings. This session is recorded and will be uploaded on YouTube, so careful what you're saying because it'll be on the internet forever. Today we have a packed agenda. We have Shanjing and Philip that's going to talk about the refactoring to application lifecycle in order for us to scale to a lot more clusters. So without any further delay, Shanjing and Philip, please take it away. Thank you.
Okay, thanks, Mac. Let me share my screen. Okay, so hopefully everybody can see my screen now. Okay, and today's we're talking about this new lifecycle subscription framework. Let's see the agenda. Firstly, we will briefly talk about the current approach and some of the gaps when we are running the deploying the subscriptions to large-scale Kubernetes clusters. And later, we will talk about this new design. So as a core, we introduced the 3 levels of app status. I will talk about these 3 levels of app status from a high level point. And later, Philip will go through the subscription status and subscription repositories, the details. And also, we will talk about this new designs workflow overview and this breakdown. And finally, Philip will run a live demo to demonstrate this new design with this status reporting. Okay, so the current approach is in our current app lifecycle framework, we firstly propagate the hub parent application to child applications on the managed clusters. And then each child application gets these resources from one of the 3 resources. There's Git, Helm, or Object Bucket repo, and then deploy the relative resources to the managed cluster. And then finally, these all of the child application status are aggregated to the hub parent application status field. So with this approach, so we can see some gaps if we deploy this application to the 2,000 Kubernetes clusters, for example. So the first gap is that we easily to exceed the single object size limit. So we try this, see if we hold all of these 2,000 cluster status into the one application status field. So we can imagine that it's really easy to break this size limit because the etcd limits at any object size is no more than 1 megabyte. The second gap we're encountering is the number limit. See if we sync up all the child application status per cluster per application, then we can see for this case, we have 100 applications deployed to 2,000 managed clusters. Then in total, we will create 200,000 application status object and store it on the hub cluster. So this is the big number and the big burden for the single hub cluster. We found that from the official Kubernetes documentation, so they're recommending that no more than 150,000 pods are created on a single large Kubernetes cluster. So the third gap we're facing is the performance impact. See, the other option is we can leave all the child application status on their corresponding managed cluster without this status aggregation to hub. But by this way, we can imagine that every time we may need to get the overview cluster status for this application, then we have to fetch all of these child application status from all the managed clusters. So that would be a big task. Okay, then with these three gaps, so here is our new design. So basically, we are introducing three levels of the application status for, and the first level is the package level app sub status. That's located in the managed cluster only. So that's for recording all the detailed status for all of the resources deployed by this application. The second level is the cluster level app sub status. That's in the hub cluster. So we are recording all the apps success or failures status per cluster. And I just want to mention that, so this cluster level app sub status, that's for, there's only one cluster subscription report per cluster. And the third level is the app level app sub status on the hub cluster. So in this level, we are recording all the resources list and all the cluster success and failure status for this app. And this app level status is located in the app namespace. So they're not in the cluster namespace. And also we are providing the cluster count summary grouped by the cluster status. So we are defining a four stage for the status of the clusters: deployed, field, propagation field, and in progress. Okay, so with these new three levels of app sub status, let's see how many app sub status related objects are distributed with this framework. We are considering this case. So we deploying 60 apps to 2000 clusters scenario. So on the hub cluster, we can see there are 60 apps. There are 2000 clusters. And for the cluster subscription reports, there are also 2K, so that's equal to the clusters on the hub. And also for the app subscription reports, the number is 60, so that's equal to the number of apps. And on each managed cluster, we can see that this app substatus, so this is the package level status CR, so that's also equal to the numbers of the apps deployed to this managed cluster. So these numbers, they are already set to the minimum. Okay, so now we can see this is the workflow to demonstrate how an app is propagate to the managed cluster, and then finally their status is calculated back to the hub. So we can take a quick look at this overview. So here, the first workflow is the dry run. So where we will connect the Git repo, Helm repo, or object bucket to get the resource list, and then we initialize the subscription report. So this is the cluster level status. And then the second workflow is the propagation. So we are leveraging the existing manifest work API to propagate this hub application to the managed clusters. See here, this is the workflow 2. And in the workflow 3, then we will do the local deployment on the managed cluster, where we deploy all the resources from the repos, and then we create the package level status resource here. So this is the subscription status. And also we are creating the cluster subscription report on the hub in this managed cluster namespace. So this cluster subscription report is for all apps. So finally, in the fourth workflow, this is the aggregation workflow. So we are generating the app level or subscription report based on this cluster level or subscription report. Then this is the overflow. And okay, so here in the workflow one, I just want to mention here. So why we are introducing this dry run workflow. So the biggest benefit is the resource list can be given by this dry run on the hub only. So we don't need to get this detailed packages list from the managed cluster. So that really help us to reduce the size of the cluster subscription report. And another thing is so this app subscription report, right now they only have the resource list at this stage. So all the cluster success feeder status will be aggregated later in the workflow 4. Okay, so here is a sample of this app level subscription report. So as you can see right now, it only includes the resource list here. So in workflow 2, that's the application propagation using the manifest work API. So I have to say that in this case, so this app manifest works resource has to be per app per cluster. For example, if we have 60 apps deployed to 2,000 clusters, then we have to create 120,000 manifest works resources. So that could cause some performance issues. So that's why we evaluate this propagation performance later. So I will talk about it, the result later. So here, this is the manifest work per cluster YAML sample here. So as you can see, so the workload of this manifest work is includes 2 parts. One is the namespace, the other is the application subscription YAML. So with this workload, so this subscription will be deployed to this particular managed cluster on this particular namespace. Okay, so let's talk about this manifest work scaling test. So this is the, something that we are really concerned. So we're running this scaling test. This scenario is we deployed 60 guestbook apps to the 2000 clusters. And the hub cluster instance time, we're using the M5 4 times large. The managed cluster instance time is the T3 medium. So this is the result. So we observed that for the first app we deployed to 2000 clusters, we create 2000 manifest works, and the total duration is about 60 seconds. Along with the app development, we can see if it is deployed 20, then we will get the 40,000 manifest works, and the total duration is around 10 minutes. So there's also 20 times of the one application deploying to the 2000 clusters. So this is a linear relationship. So if we deployed 60 applications, then we will, the total duration is 60 minutes plus 8 minutes. So because right now we are added the dry run, so the dry run need some time to connect to the Git repo and then get all the resources. So this additional 8 minutes does make sense. We also noted that the pressure on the managed clusters is pretty low. So we can see that these 60 apps are gradually deployed to each the managed cluster. So the pressure, the workload pressure is not a problem on the managed cluster. And but we see that this hub cluster crashed when we continued to deploy more apps after around 120,000 manifest works are created. So this can be explained by this one. So we found that one Kubernetes cluster is designed to contain no more than 150 total pods. So this is the recommended value. In workflow 3, we connect and download the Git repo and then get all the resources deployed to the managed clusters. And then here we will create two levels of the status. One is the package level subscription status. The other is the cluster level subscription report. So here we can see the YAML sample. That's for the package level subscription status. See here we have all of these packaged with their detailed status. If they have something wrong, then we will see this error message here. And in the cluster level, we can see this YAML sample is so this is for the cluster 1, and we can see that in this cluster 1 subscription report, we have all of the applications that deployed to this cluster 1 with their overall status. The app sub 1 is deployed, app sub 2 is filled, app sub 3 is the propagation field. Okay, now we have the final workflow that's for aggregating all the cluster subscription report to app subscription report. So in order to that, we deployed a new summary controller for doing this aggregation. I just want to highlight that this controller is not using the reconcile mechanism. So we're using the wait until a loop to load all of the cluster subscription reports every time to do this aggregation. So that makes sense because for one application status, their relative cluster status are located in all the cluster subscription reports. So every time we have to load all the cluster subscription reports. Oh, sorry. Okay, and then let's take a look at complete app subscription report YAML samples here. So here is includes these parts. The first part is the resource list. So this part is generated during the dry run, the first workflow. And the second part is the result. So that's for reporting all the clusters overall status for this application. See the cluster 1 deployed, cluster 3 field, cluster 4 propagation field. And also we are providing this summary section to highlight that how many clusters are deployed, how many clusters are filled, and how many clusters are propagation field. And we also mentioned the total clusters propagated. So this is given by the placement rule. There is a in progress summary count. So this one is a calculated field. So that's equal to the total clusters minus the deployed, minus the field, and minus propagation field. Okay, so so far, we have introduced all of these workflows from high level. One thing I need to mention that so we still need a way to get the detailed the package level subscription status from the hub. So that's why we're introducing this hub backend CLI for end user to get this package level subscription status from a given managed cluster. So this is the CLI. As you can see, that so there requires 3 inputs. The first one is the managed cluster name, and second is the app sub namespace, and the last parameter is the app sub name. And also if we deployed a local standalone subscription on the hub cluster. So there is no AppSub propagation, no cluster app level subscription report created because they are standalone. So we just create a package level subscription status in the app namespace. So that's the for the standalone subscription. And also during this new design, we deprecate the deployables API, and also we deployed. Now we deprecate the namespace type of channel and the subscription because that's mainly rely on this deployable API. So the deployable API is for writing all the resources that they want to deploy to the managed cluster as a binary field. So this is the low performance. So we decided to deprecate. Okay, I think I think so far my part is done. So right now I pass it to Phil to go through all the details of this release.
Thanks, Xinjing. Let me start sharing. Okay. Okay, so I'm going to go through the new CRDs. So that's the subscription status and the subscription report CRDs. So first, the subscription status CRD. It provides the status of the subscription, including the status of all the resources, and this is on the managed cluster only. Okay, so this is the Golang struct for the subscription status CRD. It contains just a subscription cluster status, and which has just a list of subscription unit status. So each of the unit status is used to provide the status of a subscription resource. The name, API version, kind, and namespace, those are the object reference to the resource. The phase that is used to provide the status of the resource, and it could have two possible values, deployed or failed. And in the case of failure, the error is provided in the message. So it's a very simple structure. So next we have the subscription report CRD. It exists on the hub only. And there are two types of subscription reports. There's the cluster and the application. The cluster report provides the status of all the subscriptions on a particular managed cluster, while an application report provides the status of a particular subscription with the status from all the managed clusters. So here is the Golang struct for the subscription report. The report type, that's the type of report it is. It could have two possible values, application or cluster. The report summary, this is a numeric summary. I think Xinjing already touched on that. So it is a number of clusters where the subscription is in one of these states, deployed, in progress, failed, and propagation failed. Results, that's the status of the subscription on the managed cluster, and I'll go into that a bit later. And resource, this is applicable to the application reports only. It is a list of the resources in the subscription. So the report result, which provides the status of the subscription on the managed cluster, the source here could have two possible values, depending on the type of report it is. For a cluster report, the source is the namespace and the name of the subscription. While for an application report, the source is the name of the managed cluster. And the result here is the overall status of the subscription on the managed cluster. So it could have values of either deployed, failed, or propagation failed. And the report summary, again, this is the count of the number of clusters where the subscription is in one of these states: deployed, in progress, propagation failed, and failed. And cluster here, this is the total number of target clusters. So it is a sum of these numbers here. Okay, there's a performance test that I want to highlight, which is for the aggregation of the application report. We have a new controller, the subscription status summary controller running on the hub, which generates the application reports by aggregating the results from all the cluster reports. So we want to get a performance snapshot of this controller. So the test scenario that we ran, we've created 2,000 cluster reports on the hub, and in each cluster report, we created 300 application status results. So what we're simulating here is an environment where there are 2,000 clusters with 300 applications on each cluster. The controller then would create the 300 application reports by aggregating the results from the 2,000 cluster reports. The results from the test, it took approximately 50 seconds for the controller to create the 300 application reports, and the peak memory usage was approximately 524 megabytes. Okay, and lastly, I want to go into a demo. I wanted to apply an application on a managed cluster and then show you the new CRs that are created. So any questions before I do that? Okay, so let me go with the demo. Maybe that would answer some questions. Okay, so I have two terminals here. The one on the left here is a terminal to the hub, and the terminal on the right is to the managed cluster. Here is the application that I will be deploying. It's basically a guestbook application, and this is the name and namespace of the subscription. So it'll be guestbook, a big guestbook, and it will be deployed to all managed clusters. So let me go ahead and apply that. Okay, so let's check the managed cluster. So it was subscribed 9 seconds ago, and let's look at the subscription status here. And so there's a subscription status created, and note here that the subscription status is created to the namespace of the subscription, and the name of the status is also matches the name of the subscription as well. Okay, and let's look in more details about this. Okay, so the subscription status, so this is a list of all the resources and their status. If you look at it, they're all deployed. So the overall status of this subscription on the managed cluster is deployed. There's no failures here. And so let's look at the subscription report here. And as expected, there are no subscription reports created on the managed cluster, but we should expect them on the hub. So if we look at the hub, we see there were 3 subscription reports created. The first one here is the application report. Note here the namespace matches the namespace of the subscription, and also the name of the report matches the name of the subscription as well. The latter 2 are the cluster reports, and note here that the namespace they're in are the namespace, the managed cluster namespace. Same as the name of the cluster report. The name of the report matches the name of the managed cluster as well. So let's look at one of these cluster reports. Okay, so the type of report is a cluster type, and in the results, in this particular cluster, in local cluster, the subscription was deployed successfully, and this is the reference to the subscription. So let's now look at the application report, and so the application report, the report type is application, and the resources, so this is a listing of all the resources in the subscription, so it matches what we have in the status as well, except it doesn't have the actual status. And the results here, it was deployed to two different clusters. It was deployed to local cluster and field managed 2. And in both clusters, they were deployed successfully. So this is the overall status of the subscription on the clusters, on the managed clusters. And in the summary, we can see that clusters here, that's the number of target clusters, were 2. And in both cases, they were deployed successfully. So hopefully that gives you a better feeling and better understanding of the new CRDs. Any questions?
Yeah. So for the subscription report on the namespace, it will show the status for each cluster. But if you have like 2K clusters, this result will have 2K records, or?
Right. It will have one for each cluster, and it would have this would be replicated for each cluster.
Okay. Will that exceed the size of the SED value, because it seems to be a quite long list?
No, from the test that we ran, that I highlighted earlier, I don't have the exact number, but it did not exceed. It was still less than, I remember it still being less than half of the maximum size. So with the performance test that we ran, with the 2,000 clusters and the 300 apps on each cluster, the report did not exceed the size. It was at least it was less than half the maximum size.
Yeah, and for this case, see, if we have a 2K managed cluster status into one object, so each status will have around 500 bytes. So here we just show the overall status for each of the managed clusters. So that won't exceed this size limit.
Yeah.
Okay, Mike, do you want to take it over?
Are there any other questions for this episode changes? Feel free to post feedback in the PR or in the issues as well if you want more time to review the document as well as the demo. Thank you very much, Zhengjing and Philip, for the presentation. I'm gonna hand it over to Yuan He, who will talk a little bit about the release management, closing of 0.5 release and opening of 0.6 release. Please take it away. Thank you.
Okay, thank you, Michael. Hi, everyone. This is Yuan Yuan, and I'm glad to be the release manager for OCM releases. And whoever is interested in this role, please volunteer yourself, and we can rotate release by release. So for today, first I will show the new project board I created under our org projects, so you can get it directly from the projects and our organization. Originally, we used one under community projects. That one will miss the issues logged in different repos. But for this one, I linked it to our existing repos, so you can get all the issues we have here. And yeah, if no more comments, I will close the original one under community, which is kind of misleading. Okay, for 050, we'd like to GA it in next week. So November the 5th, that's by next Friday. So there will be there's still 2 issues in progress. So please the owner wrap up your existing work and close these 2 issues. And we do see 3 policy-related enhancement proposal, but we haven't seen any progress. Please check if you want to roll it to next release, or we want to remove it from our release candidate. And for 060, so far we have all the issues shown here is our release candidate, and we plan to GA 060 in middle of January. So that will give us 5 sprints if we don't consider the festival, New Year festival. So there's still one proposal that's waiting for more comments from the community. So I do see the issue owner have the proposal linked here, and please share your comments, and we can accept it and start working on it. So any questions or comments?
I just want to mention for the app, for the 0.5 release, the app work was waiting on some feedback. So we might wait 1 or 2 one additional week to see if there's any feedback. If not, we will probably merge the PR and close the issue. Thank you.
Okay, sure, thank you. Okay.
Okay, thank you, Yuan, for taking up the release manager role for our community. I see that you organized under the projects, which is really nice. I linked the URL for anyone interested in the chat. Once again, thank you for coming to another Open Cluster community meetings. If there is no additional comment, I guess this is the end of the call. Thank you, everyone.
Thank you.
Take care.
Thanks.
Thanks, Mike.
Bye.
Bye.